In this video, I want to talk about two results that we can use to limit possible choices for zeros of polynomials. The first result is Descartes' rule of signs. This theorem says, if you have a polynomial with real coefficient and non-zero constant term, then the number of possible positive zeros is going to be equals to the number of sign change for f of x, possibly less than that number by multiples of 2. And the number of possible negative zeros is going to equals to the number of sign change in f of negative x, and possibly less than that number by multiples of 2 as well. So now let's look at an example. I have a fifth degree polynomial here. So now let's start with counting the sign change in f of x. Really, the coefficients of all terms are positive. There's no sign change. So by the results from Descartes' rule of signs, there's not going to be any positive real zeros. Now let's check the sign change for f of negative x. Let's start with write out the expression for f of negative x, which is being this. Now let's count the sign change for the coefficients of each term. So we do have the sign change once. So by the results, we can conclude there is going to be a possible negative real zero for this polynomial. So the next thing I'm going to show you is upper and the lower bound theorem. So what do we mean by the upper bound for the real zeros of polynomial? Upper bound is a number such that all real zeros of your polynomial is going to be less than or equals to. And the lower bound is going to be a number such that all real zeros of polynomial is going to be greater than or equals to. So the upper bound and lower bound theorem says if you have a polynomial with real coefficient and with leading coefficient being positive, then you can determine whether a number is an upper bound or not by determining the sign of the numbers you get from synthetic division. Okay, so let's start with checking whether 4 is going to be an upper bound for the zeros of this polynomial. Let's start the synthetic division process. We're going to write down the coefficients of this polynomial in decreasing order for powers of variable x. And we put 4 in this little box. We start the synthetic division process as we learned earlier. Looking at the numbers we get in the very last row, the theorem says if all these numbers are non-negative, then 4 is going to be an upper bound. But we do have some negatives in our results. So by the upper bound theorem, we can conclude this 4 is not an upper bound for all zeros. The next part asks us to determine whether negative 4 is a lower bound. Again, we can do this through synthetic division. We start the synthetic division process for negative 4. This is the number we get from synthetic division. If the signs of the number we get in the last row are changing alternatively, then negative 4 is going to be a lower bound for all zeros. In this case, we do have alternating sign change for the numbers we get from synthetic division. So by the lower bound theorem, we can conclude negative 4 is a lower bound for all real zeros of that polynomial.